So a simple example to understand one-sided limits is the so-called floor function. And the graph of the floor function is given here, as you can see. So how this function works is this function whose value at x is the greatest integer less than or equal to x. So let's analyze the behavior of this function at a given point. So let's consider the point x equals to 2, which is over here. So from the graph, you can see that if we approach this limiting point from the left-hand side, uh, the the closest value to 2 is actually 1.99, which is somewhere around here. And as we know how the floor function works, the closest integer value less than or equal to 1.99 is actually 1. So we have a filled in dot over here for the value of 1. And you can see from the graph that if we approach this point from the right hand side, however, we can see that the closest value to 2 is actually 2.01, which is somewhere around here. And as the floor function works in a certain way, we know that the closest integer less than or equal to 2.01 is actually 2, which is why we have another filled in dot over here. So from this example, you can see that the left-hand side the left-hand limit, which is basically what we get when we approach the limiting value from the left-hand side, we got that as 1. And when we approach the limiting value from the right-hand side, we got that as 2. So clearly they don't match. And since they don't match, are not equal, we can say that neither of the limits exist. So this is a very good example to see how one-sided limits work and how they can determine if a limit exists or not.